Hello everyone, it's June 29th. Alright, I see that we have another hard one, but yeah, we're not afraid. I thought about this one last night, and I think I have the solution. It's definitely not ON, but I think it will work. I'm not sure, I'm gonna try it. Um, yeah, we'll talk about this when we get there. So let's get this one done first. Last day where you can still cross. There is a one-based binary matrix where 0 represents land and 1 represents water. You're given integers row, column, representing the number of rows and columns. Okay. Initially on day 0, the entire matrix is land. However, each day a new cell becomes flooded with water. You're given a one-based 2D array cells where cells I represents that on the ith day, the cell on the ith row and ith column. Wait. Why? Why not as one-based coordinates? Because the whole thing is one-based. Dude, why? Why do you do it that way? I just realized the one-based. Alright, it will be covered with water. Changed to 1. You want to find the last day that it is possible to walk from the top to the bottom by only walking on land cells. You can start from any cell in the top row and end at any cell in the bottom row. So you just go from the top to the bottom. You can only travel in the 4 directions. Return the last day where it is possible to walk from the top to the bottom by only walking on land cells. Alright, so the first day, is that counting the first day? So that's the day 0. So day 0, my god, day 0, day 1, day 2, and day 3 we can now go, right? So basically, we just need to find, this is day 1. This is going to be nice. Okay. What do you think? All right, what is to go across? So we need to find a path, right? We need to find a path. It's not likely that you can run every single time. So we need to find something smarter to do. Something smarter. Or we can decide on which day it's not possible, right? Maybe that would be easier to do. Which day is not possible? What do you mean by not possible? That means there's just no way to cross, right? Which means, you start from any place on the top, then you try to go down, right? But we have 2 times 10 to the 4th. Okay. Or maybe the question is, if we start from, if I have something that I know, if we start from a certain position, then can I reach the bottom? Okay. So it's like a true and false. So at the start, everybody's true. Okay. Now we add something. Of course, that one will be false, right? And this is a false, but everybody else is still true. But this is true and this is true. Why are they true? Because you're only affecting the first row, it's fine. And then you add this one, right? You add this one. Anything below, we don't have to change. But when you add this one, anything on the right side is still the same. But everything on the top, we might have to change. So now you consider the one right above, right? So Yeah, that's, so here's the idea. I'm not sure if it's gonna work, but let's just, right. So we have a table, all right. At the beginning, everybody is good, right? Now, the first one, we say this become bad. And anything that's below it, it's not affected, so it don't do. Anything that's on the same row, but towards, no, it might be affected, okay? It might be affected, it might. So I need to check anybody that's on the same row, right? Because it could be this is a critical one. So like it's getting blocked and this one won't be able to go. So we check everything on the row to see if anybody else becomes inaccessible. So we check this, right? Basically, we just check if we can go down, right? Because go up, how do you determine like the change in state when you put some cell to be impossible to go? Huh. Yeah, because I can think about a situation where, you know, these are all bad. This is bad, this is bad. And this one can go up, right? Let's say we have a route because this is one is allowed. We can go up, around, and then we'll do this. And this cannot go this way, this cannot go this way, but they can still go this way. But how do you know it's still possible? What if it has to go... So, okay, at this, what I know is, let's say this one's good, okay? This one's good. I don't really care how it manages, right? We don't know. So we just say, this one we don't know how it manages to reach. But now we shut off one side, so it can now go this side. So does this affect? So we go back here, right? And everybody else is still going to be, let's say, good, right? Everybody else is good because we don't know the impact of this. We don't know yet. And we're trying to go row by row. Is this my belief that the effect will, you will not know the effect until you go from this and then you go up, right? So it's important to see if this one is still good. Now, in this case, this one can go down, so this definitely is good, right? So the question is, what if this one cannot go down? And we have, let's say, something on the top. Yeah, let's say like this. Right, so this one cannot go down. So it can go up. But the state on the top, it depends on the state in the bottom, right? Maybe we can, I don't know, go through them one by one and just to see if they still connect. So yeah, if it's possible, someone has to connect to the bottom. Like someone has to connect, right? So once we do this, we go through this to find if anybody still connects to the bottom, right? If we find something that still connects, then that one is good, right? That one's good because at the bottom doesn't change, right? At the bottom doesn't change, right? At the bottom, nothing changes. Like if the previous state is we still have a path, Now we change this. Now the question is, what is the current state change? So you go through the current row, okay? Then you find something that's still connected to the bottom. If it still connects, then we're good, right? Then we're good. But if nothing connects, then that's the moment that we're down. Right? Does that make sense? Every time you do one, you go through the whole thing to find if something is still connected to the bottom. If you have something connected, then we at least have one path. Right? You have one path. At least this one is good. Right? This one is good. You have, like, doing this, you didn't block this level to connect to the bottom level. So what we're saying is, you need some connection from each level to the next level, and the connection is cut if there's no more connection. It's just impossible. So impossible could be the entire thing gets blocked, or some level gets blocked so it cannot keep going, right? So here we do this, we check the whole row, and then we see there's still connection. As long as there's connection, right? Because at the bottom we know it's good, and this is good, right? This is good. Then we know this must be good, right? We keep going. Can we have connection? If we do not have connection, then this one, the thing is, if we do not have connection, this one might still be good. That's the thing, right? That's the thing that's hard to judge. Or we can just say, just check if there's anything connect, right? As long as something is connect, then we're good. That doesn't make any sense, because I can think of a situation like we can have this is connect, right? So this is connect, but look at this. I still find one. Yeah, you see? This level I have connect, and this level I have connect, but there's no connection between these two. Maybe we need to find these connects. So each level, I find a connect, I find another connect. Then what? So at each level, we will block something, right? And then you try to find which one is still connect to the next level. Okay, so we find something that still connect, right? And then we find maybe something else, so we have bunch that still connect. Then we want to know if these any connection between them. Right? So what does this mean? This means we want to know if they belong to the same group. If they belong to the same group, I think I want to use union find. What I'm thinking is, what if we get union find for every single row? Jesus, every single row. Okay, union find every single row. So every row I have a union find, okay? And every time we do this, this one gets de-unioned. We can do that. De-unioned. Right? We de-unioned. And once we de-union it, then we go through the whole thing to find everybody that still has connection with the next one. And we ask if any of these are still unioned. Well, they will be unioned, but the thing is, if it's blocked in the middle, then they can no longer be unioned. Shoot. How do you represent this? Right? It's like you wedge this, then this and this are no longer union together. Or maybe we can record the position. Okay, so like each row I have this position, this position, this position. If the connection, like I have these are the things that's connected, then I need to know whether any of these are within the same range. How do I tell that? So what happens when they're in the same range? Well, they're in the same range if there is nothing between them. Maybe this one doesn't work. It's unnecessarily complex. Maybe we start from the end. Try to see if at the end we have any path. And each time you are removing a water, so you're reviewing a land. But then how do you know, right? Yeah, all we need is just one connection from top to the current row to the next row, right? That's what we need. One connection. And we want to determine whether these connections can still be reached. So what we're saying is who at each row has connection to the next, okay? I can have, okay, these all have connection to the next. And when I do this, then we remove it. So like the first row, I have 0 and 2. This has 0, 1, 2. Have connection to the next, okay? So now we need to know whether at this level, right? At this level, because I have 0 and 2, they have connection. So we see in this level whether these have a connection or if there is something they can connect to. So also row-wise, we need to know. Row-wise, what are the range? Like if I know the because on the row we can say we wedge something, we can break the row into like this, right? And some things in the middle it doesn't go, something it doesn't go. So we wedge something into the row, and we can break the row into small chunks. Okay, can we do that? Yes, we can do that. This is doable. So we can break this into this, and now you put your value in, and these are sorted. Okay, these are sorted. So whenever you query, right? So when you query, you query the ones on the row who still have connection to the next row, right? So in this case, we have 0 and 2. So now you put 0 and 2 inside this. And for this case, this is actually just, it's not going to be this. It's just going to be one array, right? It's going to be arrays. This array going to be 0 and 2. 0 and 2. So you put 0 in it, right? Now this is the row, and we also have the column, right? We also have the column. Wait, hold on. So you also have the column of which one? Why do you have the column then? You don't need to have a column. All you need is each row. Hold on. Let me read this one more time. Let's start from the beginning. Hold on. Start from the beginning. Okay, so when we start, everybody is good. So we say each row, the range of cells that has connection to the next row is 0 to 2. Okay, 0 to 2. And not last one, we don't care. So now the first one is this. So this one becomes bad. That means we'll wedge 1 into this. Okay, and then we wedge 1 into it. Holy crap. It's going to be 0, 0, right? We wedge 1 into this. So this changed. It's no longer 0 to 2. Right? We're going to change this. Basically, we'll break it up. It's going to be like this. 0, 1. Ooh. 0, 0, 0, 2, 2. How are you going to binary search in this one? Hold on. I can binary search. I don't do it this way. I do it the start and the length. So all right, let's do that one more time from the start. Okay, start with this, and we're gonna do 0, and the length is 0, 1, 3. Okay, so we have 0, we have 3, and this is the same. 0, 3. Okay, and then we push 1 into it. Then we binary search this. Okay, we binary search this because all of these are the starting point, and this ends the starting point. We only need the starting point, right? No, we can't just need the starting. We need the length. We need to know the length. So now the starting point is 0, and binary search will push me at the end, so it's on the outside. So now I want to know. No, it's definitely in, because every time you do, you're gonna turn something that's a land to water. So now you say, okay, 0 to 3, no 0 with a length of 3, and a 1 is in it. So you break this, right? So we turn this down, and you break this into 0, 0, 1, and 2, 1, right? Starting from 0, you have 1 width, Starting from 2, have a 1 with, so you break it down, right? Then what? So these can connect to the next one. So you push one of them, so you go through all of them, 0 and 2. You'll go to the next level, okay, to see if they are included in one of the ranges, because that's what we want, right? So the current level, you have whatever is still connected to the next level. So you'll go to the next level to see if they are also in a range that connects to the next level. All right, so okay, so you go to the next level, you say, oop, 0 is in it. So as long as one of them is in it, now you gotta do all of them. The 0 is in it, 2 is in it, so you can already binary search, right? So you can binary search, and then you see if it's in it. If it's not in it, that means, holy crap, because this is gonna be a range. And this is gonna be a range as well. So you have to update the range. Oh, really? Are we doing range in this one? Oh my god, I don't like ranges. Alright, let's keep going. So next one is, you know what? I think we do have to need the last one as well. Anyway, next one is this. So we shut this down. It's 0, okay? 0, we say 0 to 3. No, not 0 to 3. I always say 0 to 3. 0 with length 3. So 0 is down, right? And this is bisect. It's a bisect left, right? Bisect left 0, so 0 has to go, and this gets changed. So it's no longer is 0, 3. This becomes 1, 2, right? And then you'll go 1, 2, you'll go down, right? You'll go down and to see if everybody is still in and a 1 is inside, so everybody's good. So you go down, now you have to go up as well. So now you have 0, 1, so you put 0 in here. Okay, your binary search, 0 is in front, right? 0 is in front. If 0 is in front, it's smaller than this, which means this is not included. So this has to be removed. This has to be removed, which is understandable because this doesn't work. So this has to be removed, right? And then you do 2. So your 2, it's within, so this can remain. Okay. So we have 2, 1 now. So far it still makes sense. Next we cancel this one. So when we cancel this one, this has to be updated. So this is 2, right? 2 binary search, 0 plus 3 minus 1 is 2. So we have to reduce the last one. So this becomes 2. All right, nothing go down, so we go up. Right? So what are we doing going down? I don't think we go down though. You block this. The thing below doesn't really change. It doesn't really matter, right? You block this. If like these still works, right? If this one still connects, it doesn't really matter. It doesn't really matter. So we don't go down. We go from top. We go step by step going up. Right? So this has become 0, 2, and now we go this level. This level will have 1, and then 1 with binary search. Okay, so this is complicated. Right, now we have 0, 2, which basically is 0 and 1 in the bottom level. and top binary search is 1, and I will do 0 plus, it's included, right? It's included, so it's only included until 1, but here is 1 and 2, right? It's 1 and 2. So 1, I see the current range is only allow 1. Yeah, closed. It's closed? It's 1, right? So it's 1 is allowed, but 2 is not allowed. Why? Because this only ends in 2. So we can check. So we know 2 has to be thrown away. Oh, this is gonna get so hairy. This is going to get so hairy. Because this level, you can have multiple. So I need to go through them. God. So for everything, binary search, and then keep going. Ugh. Whew. So anyway, so in this one, 2 gets thrown away. Because this does not connect anymore. Right? This does not connect anymore. So this becomes 1 to 1. Because this does not connect anymore. Yes, this does not connect. But this still connects. I know what? No. Yeah, it's not right. It doesn't seem right. Right? So like this one doesn't connect. But this connects to this. This is connect. So we find this is connect. What are we looking for? What are we doing? Again, what are we doing? We want to find who can connect to the next level. We also want to find who has connect on the row. Right? So this one does not connect, has nothing to do with this connection. So what are you saying? What are you saying? What I'm saying is, once something gets bad, the ones immediately above, it does not connect anymore, right? So this connection gets dropped. Right? This doesn't connect down, but this is still connects to this. Okay. All right, let's do this one more time. What we want to show is at each level, we have some cell can connect to the row below, right? Okay. And those cells can connect to another cell that connects to something going below. All right, let me do this one more time. Let's just do one more time. All right, so what do you want? Everybody's good. All right. And I have a row who are connected to whom. All right. So I say we have the range that's connected, 0, 3, 0, 3, 0, 3. Everybody is connected. And column-wise, from this to this, who do we have that's connected? We have 0, 1, 2. All of them can connect to the next one. 0, 1, 2, and 0, 1, 2. Okay, this is our starting position. Now we cancel this. By canceling this, we change this because 1 is gone. So we push 1 in, right? And because we can, binary search, anything to the right doesn't really matter, anything to the left. So the one that includes one, right? The one that includes one gets broken up. So this is gonna be 0, 1, and 2, 1. Okay? And when we do that, we also remove 1 from here. 1 no longer goes down. So now the 1 goes down is only 0 and 2. So what I want to know is 0 and 2, are they connected? I mean, can they go down? So we check, it's in there, we're good. All right, we're good. 2 is in there, we're good. If they're not in there, then we need to check if the one that's still in there can connect to 0 or 2. Then we use this to see if they're still connected. How? Well, we have whatever this, and we have whatever this. So we have a bunch of this. Then we need to know if they are part of the range. How do we know if they're part of the range? We can say, binary search. Okay. And then this is the range. So we check everything, see if it's in there. That's a possible way. Okay. So next we take out this. So once we take out this, the connection gets broken. So 0 is gone, right? 0 is gone. And this changed. So it's no longer 0 to 3. We break it down. This is going to be 1 and 2. Right? 1 and 2. So now what? Now after doing this, we need to, because these no longer don't change, so we go up, right? We go up. So we go up, right? We go up. So to this row, basically to find if anything is still good. So when we go up, this is no longer there, right? So we go through the ones that's used to connect the next one, and we see 0. Then we check if it's in there. I don't have to check. We just see to go down. So 0 actually no longer connects, right? So we remove 0. 0 no longer connects. Okay, 0 no longer connects, and 2 still connects. Right, and then when 2 still connects, we go to the next level to see if 2 connects to anything. So we first check if it's in there. It's in there, so we still good. So this is still good. Okay. Next we'll remove this. So this we change to 0 and 2. Okay, we change to 0 and 2, and then with 0 and 2, right? And then this, what does this do? Who goes to the next? So we remove 2. Right, we remove 2. Okay, when we're done, we go up. Alright, we go up. Actually, we just check the 1 directly up, and then we can remove that, because this one no longer connects, which is 2, right? This one we remove. Now after remove, we have again, this is the only thing that we need to change, right? Because this one doesn't go down immediately. Everything else is the same. So yeah, the effect is this and the one above you, just no direct connection. Then we again go to the top, right? We go to the top, or well, we have to go row by row, right? So in this row, we have 1. And 1 still works. So 2, so wait, hold on. Like if this row still works, then everything else shall still work. Because the effect, right? When you shut down a cell, if the previous one still worked, no, previous one still work doesn't mean the one above it. Alright, hold on, let me think again. At a current row, I shut down a cell, right? And the effect is the row above it. The row below it doesn't really affect. On the same row, when we did on the same row, it might affect, right? We might affect the number that can go down change, right? And then we can change this. Yeah, we have change on the row. Then we go 1 above, right? Basically, we say who still have connection down. We have 1 have connection down, and then we have like who still has connection. All these have connections, so we need to know if all of them are still good. If none of them can get to the next level, then we're done, right? So we go here, we cancel this, and then we go through, I don't know, we go through what? We go through this, and 1 works. How about 2? Hold on, so yeah, we have to go through every single one just to make sure if they still work. We have 1 still connecting. All right, so okay, hold on. So what we want is each row, the 1 connecting, they shall all be able to go down. Okay? So if that is the goal, then this one should be removed because it doesn't go down. Right? And how do I know? Because this got blocked. Right? This gets blocked. And so this can now go down. And or we need to go through every single one here. Right? We check this. We check every one. If it's part of this, no, this doesn't. This is just 1 that can go, that can connect. So each cell that can allow a path shall be marked. Each cell that cannot shall now marked. So when you mark something, Yeah, when you mark something, when you take something away, the ones below doesn't fact. So when you take something away on the same row, how do you know if you can still go? Well, you don't. That's the thing. You don't. That's what I'm saying. And yeah, I only know if they can go down, right? I can record who can go down. That's easy. We can record who has a direct go down. That's easy. We can do that. Who can go down, right? So for each row, you look at whoever it is, right? Okay, whoever it is. Oh, wait, hold on. Cells.length is equal to row times column. Oh, cells length. But it doesn't mean every time it's on a different. Yeah, it doesn't say. Yeah, I can know which one connects. Okay. So initially, everybody connects to the bottom, right? Everything can go to the bottom. And then you start shutting things down. When you shut things down, it does not affect the ones in the below, but on the same level, I'd say the one right next to it. I need to know if this one is affected. Can it still go down? So to know that, if it goes down, then if the bottom is good, then this one is good, it's not affected, right? And then towards the left, it's the same thing. Okay? And then I shut down another one. Okay? I shut down another one. And these are going true, truth is still true. And then we go a level above, and then we just see if everything's good. Because I have 4 directions to check. Right? I have 4 directions to check. Yeah, but the thing is, the level above you don't know. The level above you depends on the current level. And you can go up. Because you can say the go up, it works because of this, but now it's. So that's the difficulty, right? That's the difficulty. If we go back to front to see the first time a path shows up, that because in this case, that's maybe we can try this. I'm a little bit desperate right now because I really have no idea. Okay, so the first one shows up 3, 1. So 1, 2, 3. So this one first shows up. Everybody else is down. Okay. Next one shows up as 3, 2. So 3 and 2. How you gonna do? So we have this, and we have another cell, but you don't know if they're connected. Then we have another cell, and we have another cell, and okay, nobody's connected. So once somebody is connected, we can connect them, right? Once somebody's, then we can connect them. Okay. So on the same row, we can connect. Okay, we can connect once. On the same row, we can start connect, and then if somebody else is within reach, so we can connect. Okay, then every time we release one more, you'll connect one more, you connect one more. Then what? Every time you go through the whole thing to see if there exists a path. How? I'm thinking about union find, right? I'm thinking about union find. So in this case, I'll connect these two, right? I'll connect these two. All right, next is 2, 3. 1, 2, 2, 3. This one does not connect. This one just by itself. Right, this one just by itself. So our group only have height of only 1, right? Next is 1, 3. 1, 3. Then boom, these two gets connected. Yeah, we can see if this one is, if it is, then we can just connect. Okay, these one connected. So this actually have a height of 2. Maybe we can play around with union find and say, okay, now we have a height of 2. Once we have a height of 4, that is the solution, right? Next is 1, 1. So we open 1, 1. 1, 1. 1, 1 is this one. This is by itself. Next one is 2, 2. Right, 2, 2. Where is 2, 2? 2, 2 is this one. Okay. This one, then we connect this, boom, 1, 2, 3, I have 3. Boom. So once we hit 2, 2, we get a path. Therefore, the answer is going to be this is the last one, which means we're going to union find. Okay, we're going to union all of these together to find the first time we have the full length. So we have to design the union find to facilitate this. How do we facilitate this? So when we do union find, we group things together, right? We group things together. And when we group things together, we need to, they need to have their own. That's okay. We can like do, Jesus. We can do a 2D union find. Oh, a 2D union find. That's possible. And we union 2 cells. Okay, we union 2 cells, and when the 2 cell gets unioned, right? When they get unioned, we need to go through that parent, right? Go through that parent and go through everybody, find their parent, and we need to ensure what is its. Wait, hold on. So we need to have none will correspond to parent. We also need parent corresponding to child. All right? We need both. But we cannot have both. No, we just go find the parent. Okay? Go through everybody that has currently been. We update their parent. That's okay. I hope that's okay. And we but this is going to be like, because every time you do it, you have to go through the whole thing. Every time you do it, you have to go through the whole thing. But I don't know. I don't know. Every time you do it, you have to go through the whole thing. Yeah, every time you do it, you have to go. Every time you hit a cell that's get open up, you union with whoever you can. And once you union with whoever you can, you find their parent, right? You find their parent, but you have to go through everybody that has been released, because you need to update the parents. Okay, we go through everybody, so that's like everybody, right? That's like everybody. You go through everyone, find the parents, and you align them for this parent, the unique column and unique rows. And once you go through everything, we can have a dictionary with the count of the unique rows. And then we see if one of them has the size that we want. I mean, that might work. That might work. But I think it's very likely gonna time out. I think it's gonna time out. Honestly, I think it's gonna time out. I think it's a great idea, but it's going to time out. Because every round we have to go through the entire cells, the entire population of cells. But why do you go through the entire population of cells? Because you don't have to go through the entire population. You only go through the population of cells that has been affected, right? That has been affected. That is what you need to get. So when you union, okay? When you union, you record who their parents are. The cell that you're gonna union with. It could be multiple. You record their parents. Okay? Then after union, you get the new parent, right? And because they are union, so they're the same. So you go through the whole thing, pick out the ones with this. Pick out the ones with all this. You are still doing the same thing. You have to go through the entire thing. You still have to go through the entire thing. There's just no. All right. I have an idea, but I think it's gonna be wrong. So let's just check the hints. Yeah, I was thinking about union find. Let's see. What graph algorithm allows us to find whether a path exists? BFS. We can do BFS. But every time you do BFS, that's gonna time out. This is actually gonna be faster than the other one, I'm actually sure. Can we use binary search? Binary search? Binary search? How are we doing binary search on this? I can't keep doing this. I need to train. All right, and we are hanging. We'll do another session today. We'll do another session today. Binary search. I have no idea. Binary search. All right, I need to stop. I need to stop. I'll be back maybe in an hour and a half. All right, see you guys later. Adios.